How to correctly dimension a resistor to limit the current flowing through a LED so it doesn't burn? That is what you are about to learn in this video. The concept that allows solving this problem is Ohm's law, introduced by the famous German physics professor Georg Simon Ohm in 1827. Ohm's law is the fundamental concept of electric circuit analysis. It is a very powerful tool because it can be applied to AC and DC circuits. A great analogy to understand the simplest electric circuit is the fluid circuit where a pump moves the water through a pipe. The pump corresponds to the power supply, the pipe obstruction emulates the electrical resistance, and the water flow is a similar effect to the electric current. In the fluid circuit, the pump applies the pressure to the system, forcing the water to move through the pipe, and the obstruction limits the water flow. The electric circuit works in the same way. The power supply applies the potential difference to the circuit, forcing the electrons to move through the wire, and the electrical resistance limits the current flow. Ohm's law is derived from the basic equation for all physical systems, which states that an effect is the result of the ratio between its cause and the opposition to it. The cause is the potential difference, also known as voltage, the opposition encountered is the material resistance, and the resulting effect is the current flow. Summing up, the voltage is the pressure applied to get the electric system in motion, and the current is the system reaction. Therefore, the greater the voltage applied across a fixed resistor, the more electric current will flow. Volts are the units of voltage, amperes are the units of current, and ohms are the units of resistance. Let's now understand the practical application of this tool. If we have a circuit constituted by a 10 volts power supply and a 5 ohm resistance, we will have a resulting current of 2 amperes. You are probably wondering how to not burn the poor LED as we saw at the beginning of the video. We will add a LED to our DC circuit, and we now have to dimension the resistance correctly in order to limit the current flow to an appropriate value. For the white LED, the typical current limit is 10 mA, and the typical voltage drop is 3.2 volts. Once we have 3.2 volts dropping in the LED, the remaining 6.8 volts will drop in the current limiting resistance. If we apply our tool, we obtain the desired value of 680 ohms, which is the optimal value for our circuit resistance. If we don't have this value of resistance available, we shall use a similar higher value resistor. We must not use a lower resistance value, so we don't risk to blow up the LED. We hope that you learned how to use Ohm's law. Comment down below if you have any doubts, and we will be pleased to help. Feel free to leave your like if you find this video useful, and subscribe if you want more content about electronics and computer science. We will catch you in the next one.